車両の音と振動は車両全体の快適性、品質および性能に重要な役割を果たします。 NVH シミュレーターは車両の音と振動のデータをインタラクティブに体験することで NVH データをより理解しやすくし、設計上の意思決定をより迅速かつ自信を持って行うことができるようにします。 VI グレードの NVH ソリューション担当ディレクターであるデイブ・ボーゲマ氏は NVH シミュレーターがどのようにして完全な NVH エクスペリエンスを提供できるかを紹介します。
Hello, my name is Dave Bogema. I'm the Director of NVH Solutions at VI Grade, and I'm very excited to be here today talking to you about our new Compact NVH Simulator. Before we get to the NVH Compact Simulator itself, I'd like to cover a few basics first, and what led us to developing the Compact NVH Simulator. So let's first take a quick look at what NVH is. NVH is automotive sound and vibration, and it's one of the main attributes controlling and delivering vehicle refinement. So this includes powertrain sound and vibration. For EV powertrains, this mostly consists of tonal gear noise and motor noise, fans, and power electronics. When we speak about hybrids, then we have typical sound and vibration challenges inherent with internal combustion engines. Now, NVH also includes road noise and vibration. And wind noise is another major component. And then we have everything else that makes noise or vibrates in the vehicle. So that can be brakes, HVAC, chimes, warning sounds, anything. So I want to emphasize that sound is a very big part of this. But vibration is also covers many of these attributes. And there's a big overlap there. And many of these characteristics, you really need sound and vibration together to really fully experience that. The sound and vibration are very closely connected when we as people perceive these. Now, NVH is one of the main attributes controlling and delivering vehicle refinement and brand DNA. Comfort, quality, and character are all communicated to the driver and the passengers and the observers through the sound and vibration of the vehicle. Sound and vibration are parts of the driving experience, and consciously or not, we make decisions and form opinions based on the sound and vibration of the vehicle. So buying decision, perception of quality, reliability, and proper function are all influenced by sound and vibration. And that also includes emotional response, whether that's positive or negative towards the vehicle. Now, many types of engineering data and CAE analysis can be adequately expressed and experienced and understood visually. We can look at a computer monitor and look at the data and make a decision very easily. Now, NVH data is a little bit different. We get a lot of great information from testing, from analysis, from simulation, but these results are typically in the form of plots and graphs. NVH data cannot really be fully expressed or experienced or understood by plots and graphs and numbers. Numbers and plots and graphs are very useful, but do not answer questions like, does it sound good? Or is it better than this competitor? Or what does it sound like? To address this, we created our NVH driving simulators to enable the experience of all the various types of sound and vibration data together in an interactive, real-time driving simulator. Now, the desktop NVH simulator is the basic workstation. Virtual NVH prototypes can be created here, and the virtual vehicle models can be driven and experienced interactively with pedals and gear shift and so forth. The models are fully interactive and you have complete control over the sound. You can switch instantly back to back between vehicles. You can turn on and off different parts of the sound. And you can change the sound. You can modify that sound all while you're driving the vehicle. Now, we have more than 55 desktop NVH simulators installed throughout the world. And the software of the desktop NVH simulator is used in all versions of our NVH simulators. Now, for many years, we offered the static NVH simulator, sometimes referred to as the full vehicle simulator. Several of these have been built and delivered to customers and are in use today. The static NVH simulator adds calibrated multi-axial vibration at all the driver touch points. So this is built into the shell of a complete vehicle with expansive visuals, and it provides the evaluator the full context of being in a real car. So in the static NVH simulator, the evaluator can evaluate and experience realistic and calibrated vibration and sound in an immersive environment. And this is one of the best ways to evaluate NVH data. But the static NVH simulator does require quite a bit of space, and considering it's built into an entire vehicle as a starting point, and it generally requires a dedicated room, and quite a bit of work is done to integrate all the systems into the vehicle. So we started thinking, what if we could provide the same vibration and sound capability in a much smaller footprint that could easily fit inside an engineering office where the engineers are working and developing the next vehicles? And what if we could do this at a much lower cost? So this brought us to develop the Compact NVH Simulator. The Compact NVH Simulator is the first simulator of its kind in the automotive industry. The key focus of this simulator is calibrated, integrated vibration and sound, delivered in a system that can simulate any vehicle regardless of its inherent vibration characteristics and dynamic behavior. 7 independent degrees of freedom of vibration are delivered to the driver. So vibration is delivered at the seat, in the vertical, and the lateral, and the fore-aft directions. Steering wheel vibration has vertical and lateral vibration, and the footwell or the heel point has vertical and lateral vibration as well. This combination delivers vibration to all driver touch points in the vehicle, providing a very realistic and accurate experience. Of course, the vibration is calibrated and equalized, so the exact vibration stimulus, which simulates the vehicle, is delivered to the driver. Sound is, of course, also a critical piece of the evaluation experience, so highly accurate, calibrated sound is also provided through high-quality headphones and a subwoofer. It's really this combination of sound and vibration that delivers the unparalleled NVH experience. The driver can interact with the simulator and the virtual prototype vehicle models using the controls in the simulator. This includes the pedals, the steering wheel, a large dash, which has the vehicle speed and other information. There's multiple ways to shift gears, and there's a touchscreen included. The touchscreen not only enables the selection of the vehicle models to be driven, but it also provides a way for the driver to provide feedback on the vehicle he's driving. It can also be used to modify and control the sound and vibration levels. I'll also mention that the brake pedal uses an actual hydraulic automotive system, so it feels very realistic. And the steering motor used in the Compact NVH simulator is the same steering motor that we use in all of our VI grade simulators. So that means it provides a very realistic steering feel and feedback as part of the overall driving experience. The Compact NVH simulator uses carbon fiber extensively in its construction. The goal was to design a frame with very high stiffness that would provide accurate vibration in a relatively lightweight system that would be fairly easy to move. The frame has been designed using simulation and finite element modeling to be extremely stiff and provide a very stable base for the steering system and steering vibration module. With this structure, it's possible to deliver well-controlled and accurate steering wheel vibration. The steering wheel itself is made out of carbon fiber and is very light and rigid with no rim modes below 200 Hertz. The steering wheel is covered in a thin layer of Alcantara material to provide realistic feel of an automotive steering wheel while still transmitting an accurate level of vibration. So in this picture, you can see the steering motor up here. That's in the front there, which I mentioned a minute ago. At the heart of the Compact NVH simulator is the NVH Simulator software. Again, this software is used in common with all of our various versions of the NVH simulator, from the desktop to the compact and the static, and even the exterior sound simulator and on-road simulator. Any of the models prepared for use in any of these simulators can be used directly with any of the other versions of the simulator. The key point here is that the same software and data models are used on all the various versions of the NVH simulator. So what is the Compact NVH simulator used for? Really, it's anything where vibration is important to be evaluated. Going back to our first slide, there are multiple areas of NVH where vibration is very important. For traditional and hybrid powertrains, we have conditions like idle and lugging and cylinder deactivation, engine start and stop events, and many others. But electric vehicles are not free from vibration. In addition to road-induced vibration that may seem more prominent now that there is no engine running to mask that vibration, there's other sources of vibration in the vehicle, like from accessories, like from the air conditioning compressor. So what level of vibration on the steering wheel is acceptable if you're parked at a stoplight with the air conditioning running? In general, there are many road-induced vibrations and sound conditions like the rough road, impacts of various types, transitions from rough to smooth road, and various other road surfaces. And I think it's important to note also that in addition to the specific vibration phenomena that are important, simply having vibration and sound together brings a great deal of realism and immersion to the experience. I've actually had many NVH engineers who have been evaluating vehicle sounds for many, many years drive the Compact simulator, and they say that it adds a whole new dimension to the NVH experience. To highlight just one use case, you can use this for evaluating impact harshness. Impact harshness in particular requires high amplitudes and correct, accurate magnitude and phase in each direction of the seat, the steering wheel, and the floor pan. So here you can see some visuals with the, oops, sorry about that, wrong button. There we go. So you can see some visuals here. So this is a two-wheel impact and a single side impact is one of the cases that we can evaluate. I'd also like to look at some of the basic capabilities of the NVH simulator, which apply equally to sound and vibration, and to the desktop and the compact and all the other versions of the simulator. The NVH simulator can bring together data from multiple sources into a single unified virtual prototype. This can include vehicle measurements, measurements on test rigs or component test stands, CAE data of many different types, and all of these can be combined into a single model. These virtual prototypes can then be used to communicate NVH information to decision makers and those who need to know. And they can show stakeholders and colleagues why their input matters. One of the questions I'm asked a lot is, how much data do I need to make an NVH simulator model? Especially with multi-channel vibration data, it might appear that creating models could be quite complicated and involved. Well, the good news is it doesn't have to be difficult. It all really depends on how detailed of a model you need and what you're going to use it for. Simple level 1 models are very useful for benchmarking and high-level target setting and require very little time and data to create. Now you can break this down a little bit further into a level 2 model where you're looking at different components. That takes a little bit more instrumentation or development. And you can also build up the models from a source path contribution approach where you have the source levels or the transfer functions generated from test data or CAE data or a combination of both, and put those together and create the model from that. So one thing I'd like to mention is that the NVH simulator models can be created entirely from measurement data, or they can be created entirely from CAE data. But the vast majority of NVH simulator models and virtual prototypes are hybrid models. They're a combination of CAE data and measured test data. So often the test data will be used to provide context for components outside the scope of the immediate evaluation or task, or for data and frequency ranges that are outside the scope of evaluation and analysis. For example, maybe you're evaluating road noise, and a detailed finite element model is created, and you can generate data up to about 200 hertz. And you can play that back, but when you listen to sound that is only up to 200 hertz, it doesn't sound real. It sounds very muddy and it's very hard to evaluate. So what we can do is we can take some measured data and apply that above 200 hertz. Now when you listen to this all together, it sounds very natural, and you can evaluate this simulated data much more easily. CAE results and data are vital components of these NVH virtual prototypes. So we've worked together with several CAE suppliers to make it very easy to bring CAE results into the NVH simulator and utilize these in our virtual NVH prototypes. And this brings us to the end of the presentation. In summary, the new Compact NVH Simulator is the first simulator of its kind to provide accurate, calibrated, multi-axial vibration with sound for a complete NVH experience in a convenient size and cost-effective price. It further enables the ability to accelerate product development from concept to sign-off by bridging the gap between testing and simulation, getting you to your virtual sign-off faster. So you can drive your virtual prototypes, you can experience those, you can understand those virtual prototypes, and make your decisions easily. The Compact NVH Simulator finally provides automakers and suppliers with a state-of-the-art compact NVH simulator they've needed to truly accelerate their development process. NVH engineers can now fully and accurately experience the NVH characteristics of a vehicle and the impact of that vehicle on several various systems and components long before prototypes are available. So you can accelerate the development process and save time and money, and it gives OEMs and suppliers the competitive edge to in the quickly evolving global marketplace. Thank you very much for your attention.